Good day everyone! We are Group 6 and today we will be discussing and solving sample problems about kinematics. For our first problem, we answered problem number 1. Princess Toadstool stands on the edge of a 30.0-meter high cliff. She throws Bowser upwards at 20.0 meter per second. If Bowser falls all the way to the bottom of the cliff, let us find A. His velocity when he hits the ground, and letter B. The time it takes to hit the ground. The given are velocity equals 20.0 meter per second, distance equals negative 30.0 meter, and gravity equals negative 9.8 meter per second squared. Here is the diagram for this problem.
For the first question, we are tasked to find his velocity when he hits the ground, that is, his final velocity. So in order to give an answer to this problem, we will use the formula. Final velocity squared equals initial velocity squared plus 2 times acceleration due to gravity times the distance. And simplifying this furthermore, we will have final velocity is equals to the square root of initial velocity squared plus 2 times acceleration due to gravity times the distance. For our solution, we have to plug in the given values, and we'll have final velocity is equals to the square root of 20 meters per second squared plus 2 times negative 9.8 meters per second squared times negative 30 meters, leading to the square root of 400 meters squared per second squared plus 588 meters squared per second squared. And then we'll have the square root of 988 meters squared per second squared, which will give us the final velocity that we are looking for, which is equals to 31.43 meters per second.
For the second question, we will find the time it takes him to hit the ground. The unknown for this question is time. The formula is velocity is equal to initial velocity plus gravity multiplied to time, then derived a new formula, and it is time is equal to final velocity minus initial velocity over gravity. Then we place the givens. Negative 31.43 meters per second minus 20.0 meters per second over 9.8 meter per second squared is equals to negative 51.43 meter per second. We will cancel out the meter per second over negative 9.8 meter per second squared. We will cancel the meter and the squared, and the final answer will be time is equals to 5.25 seconds.
For our second problem, we answered problem number 6. A balloon is ascending at the rate of 12 meters per second at a height of 80 meters above the ground when a package is dropped. For this problem, we will be solving for two quantities. First, A. How long does it take the package to reach the ground? And B. With what speed does it hit the ground? Here are the given for the problem. Initial velocity equals 12.0 meters per second. Displacement equals negative 80.0 meters. And gravity equals negative 9.8 meters per second squared. Here is the diagram for this problem.
For the first question, how long does it take for the package to reach the ground? The unknown value is the time. Since the provided values are initial velocity and height, the formula change in y is equal to initial velocity times time plus acceleration due to gravity times time squared over 2 can be used. Substituting the given, it will be negative 80 meters is equal to 12 meters per second t minus 9.8 meters per second squared t squared over 2. Then we need to simplify negative 9.8 meters per second squared t squared over 2, and that will be negative 4.9 meters per second squared t squared. Then we will add positive 80 meters on both sides to eliminate negative 80 meters on the left side, and we will arrive with the quadratic equation 0 is equal to negative 4.9 meters per second squared t squared plus 12 meters per second t plus 80 meters. To obtain a positive value for the first term, we need to divide the whole equation by negative 1, giving us 0 is equal to 4.9 meters per second squared t squared minus 12 meters per second t minus 80 meters. Since this is a quadratic equation, we will use the quadratic formula negative b positive negative square root of b squared minus 4ac over 2a to get the value of time. But first, we need to determine the values of a, b, and c, which are a is equal to 4.9 meters per second squared, b is equal to negative 12 meters per second, and c is equal to negative 80 meters. Substituting them to the formula, we will have 12 meters per second positive negative square root of negative 12 meters per second squared minus 4 times 4.9 meters per second squared times negative 80 meters all over 2 times 4.9 meters per second squared. Computing all the necessary operations will give us 12 meters per second positive negative 41.38 meters per second all over 9.8 meters per second squared. Simplifying this, 12 meters per second plus 41.38 meters per second over 9.8 meters per second squared is equal to 5.45 seconds. And 12 meters per second minus 41.38 meters per second all over 9.8 meters per second squared is equal to negative 3 seconds. We will disregard negative 3 seconds since time can't have negative value, so the final answer is t is equal to 5.45 seconds.
For the second question, with what speed does it hit the ground? The unknown for this question is speed. The formula that we use is final velocity squared equals velocity squared plus 2gd. In this case, the solution is final velocity squared equals 12 meter per second squared plus 2 times negative 9.8 meter per second squared times negative 80 meters. We will get 144 meters squared per second squared plus 1568 meters squared per second squared. Then we will get the square root of it. This will be the square root of final velocity squared equals the square root of 1712 meters squared per second squared.
So our final answer will be 41.4 meters per second.
That's all for today. Goodbye and thank you.